Good afternoon. It's afternoon, yes, so I'm saying good afternoon. That's okay. What I'm trying to do this recording is for a problem statement. If in series of tosses, if you have got three edges in a row, what is the probability of next edge or next t, one minus whatever? Intuitively, it looks like because there have been three edges in sequence till now, the probability of next edge is low. Or also, there is another theory that if the next t comes in, now I have to wait for three edges to come in, so the probability is skewed in one way or the other. My answer is these are all mutually exclusive events. Hence, the probability is going to be 50% all the time. So what I have done is I have done this random number between 0 and 1, and if you look at the sum of this, there are about 104 1,048,000 records, out of which 524,000 are ones. I converted zeros to h and ones to t. Very simple calculation, and then here what I do is if B3 is H and if B2 is H and if B1 is H, so there are three H's in consecutive way, then print this. So if you could look at it from here, there are three consecutive H and then a T is printed. Here there are three consecutive H and then H is printing again, H is printed, H is printed, T is printed. So this is how it has been doing. And then what I do is here I count number of H's in column C, count number of T's in column C, and then simply calculate the number of occurrences, which is probably a probability. When the number is about a million, we should be able to consider this to be sufficient size with about 65,000 H's and 65,000 T's after three H's. So if I keep on changing anything on the sheet, it does another random number calculation. So you would see multiple times running. The probability is coming almost 50% for both the cases. And I'm going to share this sheet with you so that you could evaluate it yourself. So next comes is if 50% for 3 H's, what will it be for 2 H's? So what I did was the same calculation on column J here. If B4 is H and B3 is H, then print in J5 B5. Okay, same thing I have done. So for example, this H comes in because there are two HH in a row. Now it has changed again, two HH in a row, two HH in a row, T is printed, this T is printed, so on and so forth. And then I did the same probability calculation here, which is also coming to 50%. So whether you try to calculate for 2 HH in a row or whether you try to calculate for 3 HH in a row or 10 HH in a row, the calculation is always going to be 50% only because these are mutually exclusive events. There is one interesting thing to observe. If I look at number of the probability of one H, which comes to about 50%. See, I'm just changing some numbers here. Sorry for the speed of my laptop. It's one of the high-end laptops, but still the calculation is high, so it's taking time. This 50%. Probability of 2H is about 25%, and probability of 3H is about 12.5%. So again, it proves that these are mutually exclusive events because probability of H is 50%. The next H is again 50% of 50%, which is 25% overall. And then 50% of 25% is 12.5%. So it again proves that these are mutually exclusive events and the probabilities really will not be dependent on what was the previous data point. I hope I have given it with sufficient confidence to you. I'm going to be sharing this Excel sheet. You play around, let me know the feedback. Thank you. Bye.